All right, today we are going to be reviewing for a math test, and our I can statement says exactly that. I can review for a math test about graphing. And it's really important that you know how to review what you've already learned so that it is fresh in your memory when you're ready to take a test. The first thing we're going to review is all the different types of graphs that we talked about. And if you remember, there are three different types that we focused on. Pictographs, bar graphs, and line graphs. And if you think back, you might remember that these graphs display information differently, or data differently. The pictographs use pictures, and we show discrete data. Discrete data, remember, is data that can compare and contrast different things and are not necessarily connected to each other. And bar graphs also show discrete data. Line graphs, however, show continuous data. And continuous data means that we're tracking one thing over time. So something like the growth of one tree would be shown with a line graph. So time would be down here. It could be minutes, it could be months, it could be years. And then this would be whatever other data point you are tracking, like height. Pictographs and bar graphs generally do not use time. They're not tracking things over time. They are comparing different things. So let's move on and talk about pictographs first. All right, here we have a fairly basic pictograph. The first thing you want to notice is the title, number of pencils each student had. That tells me what we're talking about. And then I see that there's 5 different students. And then I see pictures, and then I see down here, very importantly, the key. This is what's going to tell you what each picture is worth. So it looks like Frank has 3 pencils, but I know that's not correct because each picture of a pencil equals 3 pencils. So this would be 3, 6, 9. So Frank has 9 pencils. Then I could also ask you a question and say, who has the most pencils? Well, you can see that Henry has the most pencils. He has the most pictures. And I can do, let's see here, he's got 1, 2, 3, 4, 5, 6, 7 pictures. So that'd be 7 times 3 pencils each would be 21 pencils. Then if I could ask you a question comparing them. How many more does Henry have than Frank? Well, is it 1, 2, 3, 4 pictures more? Or is it 21 minus 9 pencils more? And of course, we're asking about the actual number, so we would do 21 minus 9 equals 12 more pencils. On your test, you're going to be asked not only to use a table like this, but also to create one. So you need to be able to create a key and use pictures to show what the data is telling you. Let's go ahead and look at that next. Let's for a moment pretend that we have a library that has this many of each type of books. Science fiction is 5,000, mystery 2,000, and so on down the line. What if I wanted you to make a pictograph to show that? Well, first of all, you would need to have a table with the correct number of spaces. And I have 1, 2, 3, 4, 5 different types of books, and I'm going to need a title as well, so I'm going to need 6 spaces. 1, 2, 3, 4, 5, 6. Good. My title might be something simple like number of books, or I might add more information like number of books in the library. I am not going to create the whole graph here, pictograph, but I want to show you what it might look like. I also need to write down the different categories. So I've got science fiction books, mystery books, informational texts, realistic fiction, and biographies. Now I need to think about what key would I want. Well, they're talking about books, so I might draw a book. Not a very good book, but it's a book. We'll pretend. So each picture is going to equal, let's see here. What makes sense? What can I count by up to all of these? Well, I see that they're all thousands, so maybe I'd say each book equals 1,000. 1,000 books. Now I can draw a picture for each category, or each genre. So science fiction has 5,000 books, so that would be 5 pictures. Now I could have also done a key that like 2000, and then each picture would represent 2000. So for science fiction, I would need 2 whole books, 2000, 4000, and then half a book to show that extra 1000. So I can do half pictures as well. Moving on, we're going to talk about bar graphs. So here's a pretty basic bar graph. I want to look at the title and everything first. So I got the title, Our Favorite Sports. Our label on the y-axis, the vertical axis, says number of students. The x-axis says sports. So I can see that, yep, they're labeling sports here. The number of students, yep, it's counting by 0, 2, 4, 6, 8, 10. That means these middle lines must be the odd numbers, 1, 3, 5, 7, 9. And I could ask a bunch of questions about this. I could say, what sport do girls like the most? Well, girls are in yellow, so girls like soccer the most in this class. Which sport do the boys like the least? Well, I can see that that is here in softball and other, so that'd be a tie. I can also compare different numbers or different data points, and I say, how many more girls like soccer than boys? Well, 6 girls total and 3 boys total, so 6 minus 3 would be 3 more girls. And remember that these are discrete data points. Remember that word discrete? It means that they are taking data that is different from one another. It is not tracking it over time. Notice that down here it is not talking about time. This is sports, and this is the number of students. And continuous data, which we're going to look at next, is shown on line graphs, which changes over time. So moving on to line graphs. So here we have a line graph, and I noticed right away that this doesn't have a title. It must have gotten taken off at some point, so I need to make a title. I've got temperature and days of the week. Well, I'm going to use that information. So what is this graph telling me? It is telling me the temperature in 1 week. So now I have an appropriate title, temperature on different days of the week. So I can ask a number of questions about this. I could say, what is the temperature on Monday? Well, Monday, it was 28 degrees Celsius. I could say, what is the temperature change between Monday and Tuesday? So I have to find Monday is 28 degrees and Tuesday is 26 degrees. So I would say it was a decrease of 2 degrees Celsius. Again, big point here, temperature is tracking continuous data over time. And are days of the week talking about time? Yes, absolutely. Just one more time I'm going to say it. This is the x-axis. This is talking about time here, and this is the y-axis. And in this case, it's talking about temperature. We have the title, which is really important, and we have, it tells us what we are counting by on the side, or the scale. For a pictograph, we don't have a scale, we have a key. Also another important part of the graph. Pay attention to what you do already know and what you need to know so that you are ready to take your test.